皆さん、こんにちは. Can you hear me? Okay. Okay, thank you, Wei Wu, for setting up the remote presentation environment, and thanks the organizers for having me here. My name is Wei Wu. I'm a RISC-V ambassador, and I founded PLCT Lab since 2019, which is focusing on the compilers, runtimes, and the simulators, which is fundamental softwares. And I also co-founded the Tarsia project last year, which the aim is to make RISC-V tier 1 support for the free and open source community. Also, I, as representative ISCAS, is also sits in the TSC of RISC-V International. I also a common organizer since 3 years ago of the RISC-V China community, which is short for CNRV. And since last year, I serve as the RISC-V, not RISC-V, sorry, RIVM board of directors, and for 2 years. And the longest community I served is Hello TCC. I joined the Hello TCC since 2009. And since 2013, I became the chair of the group, and I also co-founded the Hello RIVM group since back to 2018. And now Choji PhD is taking the chairwoman of the Hello RIVM. So I'm very proud that the community has joined very quickly. And the agenda shows that we will divide my topic into 5 parts. So one is why RISC-V is future, and then why we need a new tool set called RuyiSDK, and what's the mission of it, what's the architecture and the roadmap of it. And the last part is that what I see or what I'm planning to do beyond the RuyiSDK. Okay, so first I want to share 3 basic opinions. These opinions or observations is just very simple. So first is that Moore's law has physical limits. I believe that everyone may hear about it. And there's no limit to the demand for computing power. Think about the ChatGPT and the AI industry. So we just see that everybody may see that there's an unlimited demand for the faster and more GPUs to be deployed. And the second opinion is that the complexity of the software system grows very fast. It's very fast. Think about the NA apps in your cell phone. So it runs on millions or billions of lines of code running to make up. You can send up a photo to another friend in the other side of the earth. And the second is that, which I think is most important, but get less observed, is that the number of developers who are capable of managing the complexity is limited. So the qualified developers is the number is not big, it's very limited. So it can get some conclusions or deductions. So first is that given that the Moore's law has limitations and the demand for computing power is unlimited, so the domain-specific architecture, short for DSA, will be everywhere. So in fact, we saw the trend roughly 10 or 20 years ago, and there's a direct conclusion is that there will inevitably be many free and open instruction sets, because that people will do innovations more quickly than before. They need to be faster to the market. And the second big conclusion is that open source software is everything. It's basically a fact these years, due to some surveys that more than 96% of commercial software includes or uses open source softwares. So the reason is just based on the opinions 2 and 3. So first is that the complexity grows very quickly, but the qualified developers, the numbers didn't go that quick. So we have two direct detections. So one is that only a few open source community can survive in every vertical field or small area. And the second is, which I want to emphasize now, is that only in an open source in one open source project, they may only a few instruction sets will be well maintained. So combine this reduction and the reduction I listed before, is that there's only one or two instruction-free open instruction sets will be survived. So that's RISC-V. So take a look at these people. So we see that in every software field or for the specific scenarios, we see that there's an open standard. So why? So this kind of isolation and abstraction, so it makes people can reduce the complexity of software and hardware systems. And RISC-V is just in the right time and the right good enough design to take the open start for the instruction sets. So, and we are not predicting the future. It's just a fact. In fact, last year, there were more than 10 billion RISC-V cores get deployed for profit, and even nearly 80 billion RISC-V cores will be deployed in less than 3 years. So why? Because that if a new startup chooses RISC-V, you will immediately get almost all the software you need to do your prototyping and to do the initial experiments. You will immediately get QEMU, get GCC, and clown area VM. You also can get some basic support for the Linux kernel or IoT system, just like FreeRTOS or RT-Thread, which is popular in mainland China. And once you get your prototypes, either the CPU IPs or the SoCs near ready, if you start to investigate or invest the software stack, you may be lucky enough to find that the vertical area, the areas, there are many softwares available. They are open source. They're open sourced, and the RISC-V support is already there. So that's a very good and very good and very surprising result. We just taking no more than 20 years, so has this achievement. But we talk about the success of RISC-V, but if you think look around, that no one takes a RISC-V laptop, RISC-V PC, or RISC-V tablet or pad or phone. So is there RISC-V still an embedded thing yet? Well, since this year, the answer is no. And the most astonishing result is this chip, is Sofia SG 2042. It actually has 64 RISC-V cores inside. It's very powerful. We can compile big projects like the Linux or the GCC or the OpenGDK in roughly 20 or 40 roughly 20 or 40 minutes, depending on how memory and SSD you have. So basically, and it has rapidly developed a series of projects. So the upper left is just a prototype board called EVB. I got it in February. So just a few months ago, now we have the box like the Milk V Pioneer box, which has put the new motherboard and with the GPU and with the memory and the SSD ready. So you can just buy it and open it. It supports many software systems. And also, some companies are just designing, trying to put a multiple the SD 2042 chips in one rack. So take a look at the picture rendered. It's just a prototype picture rendered from some companies. So they are up to 1022 RISC-V cores inside the one rack. So that's astonishing. You can just treat a very small cluster, mini or kind of a RISC-V cluster. And the second big thing that we want to emphasize is that Android. Android now, Android is an open source project maintained by Google, and Google just last year, they announced that they will support RISC-V as a tier 1 platform. Well, that's a very big news. You know that the Google itself as an upstream, it just accepts the ARM and ARM64 before. So the progress is very fast, thanks support and contribution from T-Head Alibaba and the Institute of Software Chinese Academy of Science. So now we can just, and the Google's help, so we can just, anyone can run the basic AOSP system on the QEMU. And if you have some knowledge about bring up and the BSP knowledge, you can run on your own RISC-V boards. So the upper right, the right upper is just an example, the LiGi-PICE 4a. So it's just available. You can buy it on the web, and it simply can run the latest AOSP on it. But you still need some hacks, not officially supported by Google yet. And the second big trend is that OpenJDK. You know that many industry companies, they put their business logicals written in Java, and OpenJDK is just the virtual machines which run in Java. So not only the OpenJDK community supports RISC-V 64, they also get some backports in the previous LTS versions, because that many industry companies are still using the old versions. Now the good news that we have 17 and 11 version get supported, and the JDK 8 is in progress, and hopefully they will be fully backported before the end of this year. And for the RISC-V PC, so I believe that you just heard the latest progress about the Fedora introduced by the Wei Wu ambassador, but I want to emphasize that almost all popular Linux distributions, they are trying their best to support the RISC-V. Many volunteers are working on this. And for the desktop, I was confident and optimistic to see that Linux desktop is almost there. And I take some example from the snapshot was taken from the OpenEULA Linux distribution, which is popular in China. So we running on RISC-V and matched. We have web browsers, we have mail clients ready, and also the LibreOffice is ready. We also even have Eclipse, which is based also IDE. So we can write code on the and match all on the Pioneer box. So, and let me just pause a minute and we see four different trends about RISC-V, and this I have a conclusion is that now we are seeing a shift. So basically from 2017 to 2022, so mostly there's a compiler engineers and system developers. They're playing the RISC-V boards, and they're trying to port the different softwares to RISC-V, and the number is relatively small. In my personal rough estimations, there are about 10 of thousands to 100 of thousands people in the world. But now in this year, due to the RISC-V workstation, the powerful RISC-V workstations and RISC-V tablets, laptops will be available this year. We will see more than 3 type of RISC-V laptops available, selling by different companies. And so I believe that we need to get ready for the next 1 million RISC-V software developers, because that there, since this year, more and more developers who categorized as application developer or the middleware developers, they will try to develop their apps for RISC-V and on RISC-V platform. So you may be surprised that 1 million RISC-V, so 1 million is very big, but trust me, it's reasonable. So only in mainland China, we have more than 8 million people who they are writing softwares for life, for work. And on GitHub, the latest estimation is that more than 94 million developers has accounts on the GitHub. So we can take this as an example. We just 1 million, just like 1% or 2% of the population of developers. So it's a relatively small number. It's just a small step. The RISC-V going to mainstream. So, okay. So now we trust we will see 1 million software developers on the RISC-V ecosystem. But why? Why we need a new SDK called RuyiSDK? What's that? So the initial idea and the plan we have behind the RuyiSDK is that RISC-V instruction has this feature. It's a modular, so you can combine different extensions and has different. The combination is very flexible, and the vendor has a very high flexibility they can design their own instructions. So what if the customer of the CPU and IP companies, they want to try different combinations? How many softwares need to be modified to adapt the combinations? So the answer is very big. So PLCT Lab is one of the developer partner of the RISC-V International. We are trying to implement a lot of new and ratified RISC-V language ISA extensions. So that's just like the KBVP, and given that we are developing many language extensions in parallel, so we thought that maybe we can just combine all the things into one source tree. We thought that it won't be that hard in the beginning, but turned out, well, that's really hard, especially for the new interns and the new developers who are not familiar with the code base of the compilers and the simulators. So we announced 2 years ago. We announced the family package project. So it simply allows users to test all combinations of the instruction set extensions. So first, we just want to include the GCC, and we want to have a QMU. So after that, for the privilege extensions, so we need to take the Linux kernel and the U-boot or OpenSPI into considerations. So the project get bigger and bigger. So we summarize some pain point. So the first that you simply, if you want to have some fun with RISC-V, you need to compile totally yourself, and the kernel, the OpenSPI, and many other open source components. So you need to combine them into a work environment. And the second makes things worse that vendors may have some of their own custom instructions to keep their competitive, and but some of them are open sourced, but some are closed source binaries. So, but as we observed before the option 3. So the qualified compiler developers are very limited. So maybe you inevitably will face a bug and cannot and very subtle failures when you're using different when you're using the different vendors compiler toolchains. So what makes things worse is that there are subtle differences between even the different versions of the same vendor, the tools that's provided by the same vendor. And the third point is that we, as an app developer, you need to distinguish what is native compilation and what is a cross compilation. The different type has different toolchain, and new beginners may get easy to mess it. And the last is that so we have many open source components, and much of them has some out of tree patches need to be maintained in different each version. So there's a kind of a set of patches need to be applied and recompiled. And if you mismatch the versions or specify all the patch sets, so some very rare bugs you can maybe you even cannot Google have a Google result, so it may happen. So that's all the pain. So given that the pain, we recognized the mission is relatively simple. So first, for application developers, we want to simplify the interface and make the decision easy. We want to narrow down the possible combinations and just give the common combinations and shorten the ISA string of the RISC-V. The second is we want to provide the same and simple process so they can change easily from different open source tools. So you can change from the GCC to Area VM or to the custom vendor toolchain A or vendor toolchain B. And the second is that we want to provide some developer environment using just a Docker or something similar to get the users easily deal with cross compilation. And the last is that we want to provide a set of examples and or templates that the developer just can start with the example. And they just compile and get a successful running result, so they can significantly lower the barrier and makes the developer easy to join the development of RISC-V softwares. So so basically there's a kind of a very complicated architecture. But you don't need to dive into the details. You just know that we just put all the open source code projects and the tools that application developer may use, and organized using a RuyiSDK package manager. So, and the huge cloud storage behind the RuyiSDK package manager, so you can just save all the development environments you can pour down to your local workstation, either on RISC-V or on non-RISC-V platforms. So we also provide many images which will flash to the target devices. So just like the small development board you have, and you need to debug and to flash the new system on it. So we're also trying to start and let the RuyiSDK package manager to have it. So and there's some example. Mostly we don't have a central repositories to store all the codes we developed. We just contribute to the upstream direct. So if you need to separate GCC patch, you can just go the GCC upstream and can download. And for some patches that is not have been accepted by the upstream, you can just find the GitHub and it's all open source. You can just simply find it and thanks for our developers. So we also have for the patches we based on the ARM project, we also open source it and try to contribute back, give back to the ARM community. And we have a lot of interns thanks to the contributors. So we have the development of the ARM repo very quickly. We also have some CI investors open, so feel free to check it out. We have an LNT, we have a Jenkins instance. And for the QEMU, for the simulator part, we use QEMU and Spike, and we also simulate the LigiPy 4a, and more RISC-V developers using QEMU. So, and this slide is kind of complicated. I just try to give a brief introduction. So it's the rationally all the principle behind the Rui package manager is just we want to simplify the development environment configurations and set up the environment using just one activate command or down or pull command. There's an example. So the developer on his own laptop and using RuyiSDK command just pull the new pure Arch RISC-V environment. Okay, so that's all for the RuyiSDK development. And I also want to share very happy to share the next big project we are doing beyond the RuyiSDK and based on the RuyiSDK. You know that we now seeing that 1 million RISC-V software developers they will join the ecosystem, and so we need to provide a tool set named RuyiSDK to support them. And that's all about the open source projects. But what if all the open source projects now we have a very good support? So then we will shift our eyes to the commercial or industry softwares. So I think that's the big thing we need to achieve. So and it takes a lot of energy, money, time to adopt a software, especially commercial software, to the new platform, even on RISC-V. So we need to unite as many chip and OS companies as we can, and to negotiate, to have meetings, conversations, to talk with more than 200 application companies to just discuss. Hey, we want your software running on RISC-V on our platform. What we can help, or what resources we need to provide. So you know that we need to combine, because that's not. There's no only one. There's no any companies or governments or or unions that can support all the energy and the engineering resources to support all the commercial softwares. So that's we need to find a way, a mechanism, or set up a new initiative to let it happen. So I'm kind of optimistic that we will achieve this in less than 5 years, and in at least 18 fields we will have important commercial softwares running smoothly and very fast on the RISC-V platform. So yeah, that's all my talks, and thank you for listening, and also and again thanks organizer having me here. And if you have any questions and you want to ask me, feel free to write me an email. I'm happy to answer all the questions that I am familiar with. And thank you.